Hello, I'm Eric Topol, Editor-in-Chief of Medscape, and I'm very happy today to introduce Jessica Richman to you. Jessica is a major citizen scientist advocate and also the Chief Executive Officer of a microbiome company called uBiome. So welcome, Jessica.
Thank you. I'm honored to be here.
Yeah, so let's first talk, before we get into the microbiome, this is a big movement going on in citizen science. That is, I think you pointed out there's something like 7 million scientists in the world total.
Right.
And there's over 7 billion people. And what if we could convert? So tell us what your thoughts are about the citizen science movement.
Absolutely. I mean, I think that, so citizen science was a term that was coined in the 70s by ornithologists. So these are scientists who study birds who realize there are a lot more amateur bird watchers than there are professional scientists who study birds, so why not incorporate the information from amateur bird watchers into ornithology? So it kind of started that thought process around, okay, how do we involve the public in science, and how do we expand the role of the public in science? And I think what got me interested in citizen science was this idea of sort of taking a step back from that and saying, from sort of how science is done now, and that example of how you could involve the public in science on a broader level, what would our world look like if we had, maybe we have 7 million now, maybe if we had 20 million or 100 million or 1 billion, even if just expanding that proportion, what would our world look like? Like, what would we be able to accomplish? What would we be able to learn? What diseases would we cure? What questions would we solve? And that really inspired me to sort of take this approach of involving the public in science. I just think it's inevitable. I mean, in the age of the internet, we crowdsource so many things, so many unimportant things are crowdsourced, and millions of people weigh in on polls of, whether a dress is white and gold or blue and gray or whatever the colors are. But they don't weigh in on really important questions, right?
And so you're bringing up this other topic, is that we have crowdsourcing of science. We have these massive worldwide projects to understand RNA structure and all these other biologic things. Who would have thought that millions of people would want to voluntarily give their time for that?
That's right. So protein folding.
Yeah, exactly. So what we're getting at is a new era where there's this information that's widely transferable. Internet is, of course, a major vector of that. And it's activating people who have interest in science. But there's a lot of people who they hear the word science and they get like kind of antibodies to this.
Yeah, it's so funny. Like on one side we have this concern about public understanding of science. People are scientifically illiterate. People don't understand, basic facts about our universe. People are uninterested in science. And then the other side, we have scientific institutions that keep people out of science, that say, unless you're, you have a PhD from the right school, and then you get hired to do a specific thing, and then you get a grant that's been approved by a committee, and all the way through the end of this process, only then can you be involved in science. So I think sort of the obvious solution to this problem is to involve people in science. And of course, there's a great value to the expertise gained, on the way to a professorship and getting a grant in terms of directing research. But it doesn't mean that you have to be the only one who then performs science. One of the things I think about a lot is how science is kind of a spectator sport, right? If you want to watch people play football, you can do that. But if you want to play football, no one is stopping you from playing football. You won't play at that level, obviously, but you can still play football, right? But in the world of science, you can't play science, right? You can't take ideas that you have, however strange they may be, and test hypotheses and see if they're true in any way that's sort of globally useful without something like the process of citizen science. So this is a real passion of mine, and this idea, promoting this idea and sort of, manifesting this idea, however you want to put it, of being able to take science from this spectator sport where people just watch people do it. You read in the New York Times about a scientific study, and it's as if you're reading, fiction. It's something you can't ever participate in, to a world where most science is done in a way that incorporates people into the scientific process.
So citizen public thing. Now, you just got your PhD.
I did, actually, yeah.
Is that from Oxford?
It's from Oxford, yeah.
And congratulations
Thank you.
That.
Yeah, it was
and
great.
that was in computer?
It was in sort of applied math, computational social science.
Okay, got it.
So it's sort of data science applied to social science data sets.
Okay, well, that's great. So now you're not just a citizen scientist,
I know,
you're a real scientist.
But this
you're
is
one
another,
of the 7 million.
Well, I'm not employed at a research institution. I'm not getting an R1 grant anytime soon.
Right.
So I think that's actually a very interesting point too. Is that I came from a very different field, right?
Yeah. So tell us about your background, where you worked before.
Yeah. So I studied computer science and economics at Stanford. Then I got a fellowship to go to Oxford, and it was while I was there doing the PhD that we started uBiome, and I'd done most of my research first, so I was able to sort of write things up and then get the PhD. But the sort of interesting piece about that is that as a person who is not specifically focused on the microbiome, not a microbiologist, not even geneticist, how would I ever gain access to this world to be able to understand how the microbiome can affect the human body, what the implications of that are? So I really think there's a broad role for democratization, not for everyone certainly, but also for people from other fields who may have something to contribute.
Yeah, so here you are, you have this background, interested in citizen science, crowdsourcing, and then there's this science moving forward on the microbiome, which is going at a pace that's really unprecedented.
Oh, it's breathtaking. If you look at the
list
of articles,
and
Google
its connection
Scholar.
with whether it's diabetes or cancer or heart disease. I mean, it's just really incredible. So here you get involved in the hottest area of biomedicine in many ways, right?
Yeah, I mean yes, and I'm very happy and honored to have the opportunity to do that. I think a big part of it is, so one of the things I studied at Stanford was there's sort of this optional honors program you could do in sort of looking at scientific revolutions. It's called Science, Technology, and Society, and so this idea of how you could how does scientific change diffuse within a population? Why is it that how did the bicycle come into common usage? How did the birth control pill come into common usage? Are there any similarities in the way this is done? And this really fascinated me, this idea of how you could use technology to create social change, how technology itself creates social change, whether you want it or not, and maybe in good ways and maybe in bad ways. So I sort of had this overview even before I knew about the microbiome of how these changes can happen, and then
you were looking for a revolution.
I was looking for maybe that's a good way of putting it.
I got you.
I was looking for a way to have that kind of impact.
You had a co-founder.
Yes, I have a co-founder.
You have, yeah. Was that a fellow interested into the microbiome?
Yeah. So his background is he was a PhD student when I was at UCSF in biophysics. Joe DeRisi, sort of leading virologist, was one of his professors there, and he was the one that sort of showed me these parallels between, because we're both he's a computational biologist, I'm a computational social scientist, and we're sort of looking at the methods that are used in both of these fields and seeing the similarities. Like, these are not very different from each other in terms of technique, but in terms of the importance of what you work on computational biology, I think that side just wins. Right? If you sort of look at the future of human health and the microbiome versus analyzing Facebook data sets, I really think there's sort of no contest here. So this was sort of what got me really interested in this, is I could take these same techniques that I was using in a different field and apply them to something that was just about to happen, and make it happen faster and make it happen better.
So when did you form?
So we started uBiome in October 2012, and we started a crowdfunding campaign in November 2012.
Okay.
So it's just like we formed the company.
So it's just 3 years.
Yeah, just 3 years.
And you now have had 350,000 people more.
So it was 50,000 actually.
Oh, 50,000.
Yeah.
Okay, I'm sorry.
Yeah.
50,000 people who have sent their poop samples to you.
Poop and other things too.
And
so
others, not just
and mouth.
Not just the microbiome of the gut, other
microbiomes too.
All right, and so they send it to you, and what do they get? And by the way, how much does it cost to do this?
So we currently have a consumer product. It's $89 per sample, and it's less if you have a subscription or if you do more than one sample at a time. We're branching off into the clinical space, so there'll be kind of a health and wellness consumer product on one side and a clinical diagnostic product sold through doctors, sort of a more traditional diagnostic on the other side, which will have different pricing, obviously. But on the consumer side, you send in you swab your toilet paper for the gut sample, you swab your mouth or your skin, or whichever other site for the other samples. You send it back to us. We sequence the microbiome in our lab using lab proprietary techniques that we've developed. Then we give you your results, and these results are, they've ranged from the very beginning. They were sort of a list of bacteria, and now we're kind of expanding the range of what we're saying. So it's not just a list of bacteria, but which ones are most unique to you, which ones have changed the most, trying to score your diversity versus other types of microbial diversity, trying to score whether or not your probiotics are working, or prebiotics if you're
taking them.
If you're taking them, like, how can you...
Do they really work?
Are they working? Well, the thing is, sometimes I think the answer is it depends, and the question is, it's very personalized, right? Because you're taking the microbiome is kind of made for personalized medicine, right? You're taking an organism hoping that it starts to grow in your microenvironment. And the only way to know if it did is to see if it's there, living in your
Have you had people,
microenvironment.
on the other hand, who
Yeah.
done the samples before and after they took a course of antibiotics?
We have. Oh, yeah, that's a really dramatic one.
Is
you
there-
can just see,
yeah.
oh, man, like diversity within like a day just goes back. And then the question is, how does your diversity recover over time, right? Does
Right.
it take a week? Does it take a month? Is it just not recovered? 2 years later, there was a study that was published in the past couple of years about how 2 years later, people still have diminished microbial diversity after one course of
Yeah, no,
antibiotics.
it's pretty striking. Now,
Yeah.
right today, you're a consumer product. You're not making any medical claims.
Exactly,
You're
correct.
just getting people curious about their microbiome
Curious about their health,
to get
personal
some
experiments.
some data back.
Yeah.
But you're pivoting. You're becoming a more
we don't-
medical entity?
We don't use a pivot as an extension.
Extension,
So it's not like
okay,
we're going to,
okay.
well, and it's also because we're not stopping using
No,
the
no,
original one, right?
extending is probably a better
Yeah.
term.
So
Okay.
we start off with, just sort of the microbiome. But we realized we were finding some really interesting things in our data that we couldn't tell people because, a test that is not processed in a CLIA lab, ordered by a doctor, doesn't have sort of the heft of the medical system behind it. You just cannot tell certain things. People think.
Can you give an example?
I think a really good example is about pathogens, for example, right? Like you can't, even pathogens you detect, you can't tell someone who's in a health, who's
Like they
using,
have C. difficile or
right,
something like
exactly,
that?
Right,
Okay.
exactly, right? You can't tell people things like that. So there's a very broad range of things that we can, in the medical context, tell people that are really valuable. And so we wanted to expand for a number of reasons. One is just sort of responsibly, if we know something, we want to be able to tell people. And the other one is that, we're kind of making a product that's much more useful because it will not only tell people about health and wellness, but also tell them specifically about medical questions.
So in order for you to do the medical extension,
Yeah.
you have to get a CLIA
so
lab,
CLIA
FDA
lab,
approval, all these things?
Well, it's an LDT. It's a lab-developed test
Okay.
processed in a CLIA lab.
Okay.
But there's you have to have doctors ordering the test. You have to have, comply with all the CLIA regulations. There's also certain states of additional regulations. CAP is sort of the College of American Pathologists is an additional certification that isn't legally required, but it's
Right.
a good idea, and that's something we're moving toward. So I think there's as I learn more about these regulations, I come to respect much more what they're trying to do and how they just tighten up the process. In a research lab, you think you're doing things well and you do your best, but in a CLIA lab and then in a CAP lab and in New York State has even further regulation, you check every last thing to make sure you're doing it perfectly, which I think is great.
Right. Now, there are other companies
Yeah.
that similarly are offering microbiome tests. And you can name them. I'm sure there's at least 3 or 4 that I can think of. How are they different than uBiome?
So we were the very first in this space,
Okay.
and we have the largest data set that allows us to better understand human health. As far as microbiome tests in the market, I'm actually not familiar with others that are either direct-to-consumer or are offering a clinical diagnostic, sort of qua microbiome. Like there are companies
some
that
are
do,
maybe just research tools,
yeah,
like
they're
American Gut.
Yeah, so American Gut is a research tool, not doesn't have this sort of clinical component and very different sort of structure. The purpose of American Gut is to offer data to the scientific community from the citizen scientists,
So
not to
These
provide
are,
it.
these are citizens that are donating their
Right,
microbiome
exactly,
for research.
Exactly.
Do they
as
get the
opposed to-
results back?
They get the results, but they get sort of a PDF emailed to them, and it
I
isn't
see.
like they don't put a lot of energy
Right.
and attention into sort of because that's
see.
not the purpose.
Right.
The purpose
It's
is scientific
a pure
research.
research mission.
Right, which is actually nothing wrong with that.
But you're
It's-
doing that
yeah.
too with your sample of people.
We
right?
are. So we're doing what they're doing, but from the perspective of personal genomics, not from the perspective of getting data for science.
Right.
We do both of those things, but our focus is on user experience in a much bigger way. So that's American Gut, and I don't know of any others that are sort of doing exactly this kind of service. I have no doubt that there will be many more,
Right.
Because this is an emerging area and there's room for lots of different people who are
But
doing it.
if I'm a
But-
consumer and I want to know something about my
Yeah.
microbiome, I just got
You come to us. That's
it?
right.
Okay.
That's right.
That's good to know.
Yeah.
Because there are a lot of people that are curious about this, and
That's right.
it's obviously a much more important area than most people ever acknowledge. Or I think over time we're starting to realize this is actually pretty darn big.
Yeah.
And in fact, a lot of the heritability that was missing from the sequence of DNA is starting to show up in this microbiome.
Yeah, that's very true.
So it's quite an exciting field. Where are you going to go with this? You have a contract with the CDC, is that right?
Yeah. So we're doing a lot of research collaborations. That's one of them. We do, I said over 90, probably over 100 collaborations at this point with different researchers. And I think, so we're going in a number of different directions. So one is sort of a Fitbit for your gut, kind of health and wellness kind of direction. The other is to collaborate on useful research as much as possible. And then the third is sort of in this clinical diagnostics area. There are a lot of companies, and this may have been what you're thinking of, they're taking therapeutic approaches to the microbiome. Because there's bound to be a tremendous amount of new approaches to small molecule drugs, probiotic cocktails. There's a lot of value in that area. That's not our sort of DNA, that's not our approach, but I think there are going to be sort of on both the therapeutic and the diagnostic side a lot of interest. And
now,
so, yeah.
you haven't yet published anything, but that's in the works?
That's in the works, yeah.
Okay.
So
are you going to eventually
like
take all these tens of thousands of people and share that data with other microbiome researchers so we can really accelerate?
This is the thing. So when we first started, we had a lot of debates around this because American Gut was launching around that time. They launched just a little bit after us. And they took the approach of your data is going to be published on the internet. Full stop. If the purpose of this project is to give data to scientists, and we want every scientist in the world to have access.
Open Humans, that's a big project.
Right, exactly, right. So that was kind of the approach that they took, and then they joined Open Humans after that.
Right.
And for us, we kind of saw this absolute trade-off between privacy and scientific access, right? Like you can't have both at the same time. And from our perspective, what we thought is, okay, we don't want to share it with no one, and we don't want to share it with everyone. We want something in the middle. So what we decided is we share with researchers that collaborate with us, that we know who they are, what they're doing. They've signed a research agreement with us that they won't, publish it on the internet or sell it to anyone or do anything that, we wouldn't want them to do with it. But they can have access. So that's kind of the middle ground. I don't think that there's a time, I probably shouldn't say this because then there'll be some good reason to do it, but I don't think there's a time where we'll just say, here's your data, it's all over the internet. Sorry guys, you thought it was private, but now everyone can have access to it. I think
but if you're, let's say the CDC says, Jessica, we need to know about if this shows up in all your samples.
That's right.
Would you then comply with that?
Depending on the situation, obviously, but I think so. That's kind of the purpose of why we're putting this together, is that we can use it for public health purposes.
Well, that sounds good. Now, anytime you do a disruption, there's lots of people saying, this is bad.
Right.
We just came from a session saying what you're doing is harmful.
Right.
So how do you respond to that?
Well, they're saying it's bad in different ways, right? Like they say that it's bad. People don't say anymore very much that it's bad because the microbiome doesn't matter. Like I think
we're kind of getting over that one.
That one, I think people just start saying. People say it's bad because people shouldn't have access to their own information. I think we're also kind of getting over that one.
I hope so.
I hope so too. I think what people are concerned about, legitimately concerned about, because these are concerns that we also share, is that the information is shared in a way that's understandable, useful, medically relevant, where that's important. That it's that it's reproducible and sensitive, it has the right sensitivity and specificity parameters. Like all of those kinds of things are important, and that's what you would want of any other technology, right? Whether it's on the medical side, to a much more rigorous standard, and on the consumer side, to a sort of broader understanding of health and wellness, in terms of probiotics and food and things like that.
Mm-hmm. Well, it'll be interesting to see how this goes forward.
Yeah.
If I understand it, the main new directions are beyond this initial consumer path. Mm-hmm. It is trying to work through the whole medical community established path with the LDTs and the CLIA and the CAP and all that stuff.
Yep.
Anything beyond that?
I think that's a lot to start with. There's a lot that comes after that as well. And I think we hear a tremendous amount of interest from the medical community about the microbiome, and there aren't ways for doctors. Right now, if you say, I'm a doctor fascinated by the microbiome, what do I do? Mm-hmm. A lot of them are buying consumer microbiome kits because they kind of don't know what else to do with it. And I think that going forward, there will be a lot more information for doctors to be able to use this information in their practices. There are some there are fewer, or maybe I just don't talk to the doctors who say something like, oh, the microbiome, that's not important. What I hear a lot is, it's so important, I know it is, but what do I do? Exactly.
And it's also going to be the quality of what you're reporting back.
That's right.
And as you said, you're getting more granular, you're getting more potentially useful data. Also the larger your sample, no less the whole field in general, the more informative it becomes.
Exactly.
So those are good things. Well, Jessica, it's really been wonderful to discuss this with you.
Yeah.
Thanks so much for sharing your arc in your career and that of uBiome, and in another way teaching us about not just citizen science, but also kind of the path of the microbiome moving forward. So thanks very much.
Yeah,
Thanks
thank
to
you so
all
much.
of you for joining us on Medscape, a really interesting discussion with uBiome, Jessica Richman, and we look forward to having you on more sessions with one-on-one on Medscape.